Okay, so we're going to be factoring out the greatest common factor. Factoring is basically the opposite of simplifying a polynomial. So just real quick, if you look at 2x times the quantity x plus 3, if you were to multiply this out, you would get 2x squared plus 6x when you distribute your 2x. So what I remind you of is that this is the factored form of this simplified polynomial. Okay? And so our job today is going to be going from the simplified form to the factored form somehow. And you need to think of it as the opposite of distributing. So how do you do that? So if you want to go from this bottom one to the top one, you look at both of these terms, and up here, the first thing you do is you multiply each of these by 2x. So here you should look at both terms and say, is there anything that's common that you could divide each of these by? And you can say, well, yeah, 2 will divide evenly here, and then x would divide evenly into both as well. Okay, so what you would do is you would pull your 2x out to the front and then figure out what you have to multiply by on the inside so that when you distribute your 2x, you get this. Okay, so let's sort of put that practice to work. Here we have 2x squared minus 8x, and you want to figure out something that divides evenly into both of those, which we'll call the GCF, the greatest common factor. Well, 2 goes into both. That's the biggest number that goes into both evenly, and x goes into both. So 2 times x is the greatest common factor. So what we'll do is we'll pull the 2x out. Now we have to figure out what to multiply it by or distribute the 2x through to get this. Well, to get a 2x squared, you'd have to multiply the 2x here by an x. So 2x times x gives you the 2x squared. To get a negative 8x, you'd have to multiply the positive 2 by a negative 4, and you've already got the x. That gives you the negative 8x. And so this is the factored form of this polynomial. Okay? So another way to figure out what goes inside here, this x minus 4, remember if you distribute, you multiply. So if you want to pull something out, it's like dividing. So to figure out what goes inside here, you would divide each of these by 2x. And the 2x squared divided by 2x is just the x, and the negative 8x divided by the 2x is the negative 4. So that's another way to figure out what goes inside the polynomial, or inside the parentheses when you factor. Okay, so we have 3 terms now. We have to figure out what comes out of all 3 of these. So I can see that p goes into all 3, so my GCF is going to have a p. And p to the first power is the biggest one that's common to all 3, so I'll have p to the first power. And then I've got a q squared, and a q to the fourth. So q squared would divide evenly to all 3 of those. So q squared is the biggest q factor. So we pull the GCF out, and I'll sort of employ the second principle we talked about in the last example. To figure out what goes inside here, I'll divide each of these by pq squared. And so when I pull out the pq squared from the first one, I have p cubed divided by p, that leaves p squared, and the q squareds cancel. Pq squared divided by itself is 1. People often forget this 1, so I'll highlight that just to point it out. Very important. When you factor something out of itself, you're left with a 1. And finally, the last term's a negative. P to the fourth divided by p is p cubed, and q to the fourth divided by q squared is q squared. So you can always check your answer if you'd like by redistributing and seeing if you get this, and you may want to do that to check. Otherwise, this is the factored form of that polynomial. Here's an interesting example. We have 3 terms here, so I need to look at these 3 and say what divides evenly into all 3 of those. And the only thing that I see in common to all 3 is the x plus 2. So in this case, the GCF is the x plus 2. So I'm going to highlight those, and that's what I'm going to pull out of all 3. And if I pull out the whole x plus 2, my first term that's left is a 2 minus, when I pull the x plus 2 out of here, I've got just the 4x, and when I pull the x plus 2 out of the last one, I get a positive 3y. Now it's not necessary to use brackets here. I just did it because I had parentheses out here as well, so I thought I might need them, but in fact I could have used parentheses here as well.